Implicit differentiation can help us with trig, specifically with the inverse trig functions. So what I'd like to do is I'd like to take a look at them, and I want to talk about the derivatives of the inverse trig, sine, cosine, and tangent. I'm going to give you what they are, and then one of them will actually do it out longhand using implicit differentiation to show that it is correct. So first, the derivatives. If I have y equals the inverse sine of x, the derivative of inverse sine is 1 over the square root of 1 minus x squared. That's my first identity. Y equals the inverse cosine of x. The derivative of inverse cosine is negative 1 over the square root of 1 minus x squared. And then finally tangent, y equals the inverse tangent of x. The derivative of inverse tangent is 1 over 1 plus x squared. So these are ones that we just need to know, to be able to know them, to recognize them. Whenever we see inverse tangent, we know that this is it. Do we need to memorize them? Probably not, but just be able to recognize them. So I'd like to prove one of these derivatives by doing things implicitly. It really doesn't matter which one. They're all very similar, and as you see one, you can probably figure out the other ones. So let's take a look at inverse sine. Now first, if we look at a sine function, y equals the inverse sine of x. Well, this really means that the sine of y is equal to x. Remember what inverse means. So if we take a closer look at the sine of y equals x, and we're going to differentiate this implicitly. So we're going to take the derivative of this, of the sine of y equals the derivative of x. The derivative of sine of y is going to be cosine y times dy dx equals the derivative of x is 1. Solving, and I get dy dx is equal to 1 over the cosine of y. Now, what's going on here with cosine? The cosine, because we're doing inverses here, you've got to remember that the cosine of y is going to be greater than or equal to 0. Why? Because for inverse, we know that y is going to be between negative pi over 2 and pi over 2. So let's take a closer look at cosine of y here. If I think about the identity, we should remember the Pythagorean identity, sine squared y plus cosine squared y equals 1. If I solve this, cosine squared y equals 1 minus sine squared y. Then the cosine of y equals the square root of 1 minus the sine squared of y. Substituting in, if this is the cosine of y, and this, I get sine squared here, so kind of combine these two things, and I'm going to get the following kind of very strange, awkward formula here. 1 over the square root of 1 minus sine squared y. But what is that really? Well, what is the sine of y? The sine of y is x. The sine of y is x. So this is really 1 over the square root of 1 minus x squared. And there's the identity. There's the trig identity proven. Okay, so just a short little video here talking about the inverses, looking for them, and then using them. You'll see a couple of examples in the homework tonight. It doesn't get too crazy with the trig, though. So nice, quick little video here.